Hello, my AP Chemers. I thought we would review Chapter 5, Thermochemistry, because there are so many different ways that you can calculate delta H or Q or heat, and so sometimes it can get a little bit confusing. So this is kind of like a summary of all the different types of calculations that we have had. The first one is using Q equals MC delta T. So when do you use Q equals MC delta T? That's when you have just one substance and that substance stays in the same phase. So if it was a liquid to start with, it ended up as a liquid. So no phase changes, basically, is what I'm saying. And usually you are given 3 of the 4 variables. So out of these 4 variables, you're given 3. You're trying to find the 4th one. The units that you end up with are joules for Q. Okay, let's look at the next one, phase changes. So from its name, that tells us that we're going to use it for phase changes. So again, one substance, but you do have a phase change, but no temperature change. So if you have a phase change and a temperature change, you got to do a combination of MC delta T and Q equals ML. For Q equals ML, the L stands for latent heat of fusion or vaporization. So you use this for melting, for freezing, use fusion for that, and for vaporization and condensation, use the latent heat of vaporization. You just use positive if it's endothermic, negative if it's exothermic. So melting is endo, so use the positive, freezing is exo, vaporization is endo, and condensation is exo. All right, calorimetry, everybody's favorite. So when do you use calorimetry? So you will see either the word calorimeter or bomb, or you have 2 substances starting at different temperatures, or let's see what else. You have a reaction happening in water. So reaction in solution. Like for example, I'm taking magnesium and adding it to HCl solution or something like that. Or mixing of 2 solutions. So for example, I'm taking some HCl and I'm adding NaOH to it, and then we have a change in temperature with change in temperature. I think that's all the ones that I can think. Oh, you can dissolve. Dissolving salt with change in temperature. So all of these are instances when we would use calorimetry. And what do you do when you use calorimetry? You say Q of system equals negative Q of surroundings. Then you ID your system and surroundings. And then you either split up one side or both sides. So you either say Q of system equals negative MC delta T of your surroundings, or you do MC delta T of system equals negative MC delta T of surroundings. You would use this one right here if you are solving for the Q of system or delta H of system. You would use this one if you're solving for the mass or the specific heat or one of the temperatures of the system. All right. Now those three methods, all three of these, your answer should be or I should say your units, let's say units for your Q or delta H are going to be joules or kilojoules, because for all three of those it's going to be for a certain amount, a certain mass. Okay, let's move on to stoic. So for stoichiometry, usually you're given an equation with its delta H of reaction, and you're usually either given a certain mass and asked for the delta H for that certain mass, or you're given a certain amount of joules or kilojoules and asked for the amount of the substance that you need to use. Now that one, the units depend. So if you're trying to find it per mole, then you're going to get kilojoules per mole. But if you're trying to find it for a certain amount, then it's going to be in joules or kilojoules. Okay. Next, for these are typically, the answers are gotten from tables. And so for these, your answer is usually kilojoules per mole or kilojoules per mole of reaction, either per mole or per mole of reaction. So let's start with Hess's law. So Hess's law, you are given several steps, equations with their delta H's, and asked to find delta H of the overall reaction. And you manipulate these steps in order to add them together to get to the overall equation. That says manipulate and add together to get to the overall equation. So you'll know this one because you're going to be given like a bunch of different equations with their delta H's. Let's see, next one is bond energies, and we're going to look at this in chapter 8. So don't worry about this one for this chapter, but I want you to have this for your, like I said, your semester exam or your final exam or the AP exam. So it's not in this chapter, but basically you will be given bond energy. So you'll know that it's bond energies because you're going to be given some bond energies or enthalpies. And so you'd say delta H of the reaction is the sum of the bonds broken plus the sum of the bonds formed. And in your table of bond energies, the bonds that are broken, that takes energy, so you're going to get positive values, and these are for the reactants. The bonds formed, these are for the products, and you'd use the negative values because it releases energy when you form a bond. And then finally, heats of formation. How would you know that it's a heats of formation problem? You will be given heats of formation, and usually ask for delta H of the reaction or the heat of formation of one of the reactants or products. And so for this one, you'd say delta H of reaction is the sum of the delta H of formation of products minus the sum of the delta H of formation of the reactants. Now, even though bond energies are not on this test, but I do want to point out, when you're studying for your final or semester exam or something like that, these two are mixed up a lot. So watch out that you're using the correct equation for them. So when you're using heats of formation, you do products minus reactants. When you're doing bond energies, you add them together, but you use positive for the reactants and negative for the products. So this is a little summary of all the different ways to calculate delta H. Hope this helps.